All right, so operations with scientific notation. Let's just go back to some basics of scientific notation. The point of scientific notation is to take a large number like this one and rewrite this without all those zeros, right? So we have, what do we have? 3,800,000, right? So we want to rewrite this in scientific notation. So scientific notation must have a single digit here, right? So we want a single digit. So the furthest single digit to the left, or single digit, that's non-zero, okay, would be my 3. So 3, followed by a decimal, so 3 point something, right? And then every non-zero digit after that. So the only non-digit zero after this is 8. So 3.8, and I do not have to include the trailing zeros. That's me. So if I am putting my decimal here, question is how many times do I move, or how many places, or how many numbers, or how many zeros do I have after this one? Yes? Yeah, so I got 3, 6, 9. So this would be 3.8 times 10 to the 9th power. Right? And that's just your review of scientific notation, right? So you want a single non-zero digit number, decimal, followed by any digits that are non-zeros. So hypothetically, if this was, let me just rewrite this one, if this was 3, 0, 8, 0, 0, 0, 0, 0, 0, 0, 0, then this would be 3.08 times 10 to the 9th. Okay, so make sure you include every digit up to the last non-zero number. Okay? And vice versa, if you have 2.26 times 10 to the 10th, then all this is really asking you to do is take this decimal, 2.26, and move it over 10 times to the right and fill in every zero you need after that. So this would be 22, 600, 000, 000, 000, 000, right? So just a quick little review of your basics of scientific notation. All right, and one more quick little review. If we have the positives going to the right, then we could also have numbers that are less than 0. Okay, so in this case, the first non-zero number that I'm seeing is here at the 4. So this would be 4.12. And this time I'm moving my decimal to the left, so times 10 to the negative, right, because I'm moving left. And how many places am I going to the left? 1, 2, 3, 4, 5, 6, 7. So times 10 to the negative 7 would be the scientific notation of this decimal. So again, if you have scientific notation, 5.26 times 10 to the negative 5th, I'm simply just taking this decimal, moving it over 1, 2, 3, 4, 5, and putting my new decimal there. So 0.00000526 would be my answer to that one. All right, so just a quick little review of scientific notation. We're going to move on to just some operations with scientific notation. All right, so you have 8.2 times 10 to the 15th times the quantity of 2.4 times 10 to the 13th. Okay, so how I'm going to look at this, since this is all multiplication, if you think about the properties of multiplication, 5 times 3 times 2 times 7 is the same thing as saying 3 times 2 times 5 times 7. Do you agree? Okay, so using that information there, or using that property, this is the same thing as saying 8.2 times 2.4 times 10 to the 15th times 10 to the 13th. And now I do not expect you guys to write this down every time, but just to show you the visual of this, right? So it's multiplication, so I'm just rewriting this. So what I'm going to do is going to multiply the 8.2 times the 2.4. So can somebody help me with that one? 8.2 times 2.4, yep. 19.68, excellent. And then I'm going to multiply the 10 to the 15th power times 10 to the 13th power, which is going to be times 10. Keep your base, right? This is where the properties of exponents come in. 10 to the 28th power. All right, so I have 19.68 times 10 to the 28th power. And then I'm going to ask you, is this in scientific notation? Well, it kind of looks like it, right? But there's something slightly off on this. What's off? Yeah, there's 2 digits here, right? So this decimal should not be here. This decimal should actually be right here. Okay, so this should actually be written as 1.968, right? Because it's going to be a single non-zero digit, and then times 10 to the, well, now if I move that decimal, that 28 is no longer going to be a 28. That 28 should change to a, yeah, it should be changing to a 29. So right now, if I were to leave this as it is, right? So if this was 19.68 times 1028 to the 28th power, I would take this decimal and move it to the right 28 times. But since I'm moving my decimal, since I'm putting my decimal here instead, I'm going to add one more to this. So 28 and 1 is 29 times. So 1.968 times 10 to the 29th power. I'm going to throw some negatives in there. So same concept here, except I'm going to shortcut this a little bit. I'm not going to rewrite it. I'm going to say, okay, I'm going to have 3.2 times 6.5. One more time. So 20.8, and then times 10 to the, okay, so I'm going to keep my bases and add my exponents, negative 20 and negative 16, negative 36. All right, so we have 3.2 times 6.5 is 20.8. 10 times 10 to the negative 20 times to the negative 16th, keeping my bases as 10 and just adding my exponents, negative 20 and negative 16, negative 36. And again, is this in scientific notation? The answer is no. Okay, so this should be 2.08 times 10 to the some power. So if we're looking at this, this is negative, yes? So off my original 20.8, this is moving, this is taking the decimal from here and moving it 36 places to the left. Yes? Well, now I'm actually putting my decimal here. So what am I doing now? What should this be? Yeah, so I don't have to move it 36. I'm going to take away 1, so, or I have 1 less place to move it, so this should be to the negative 35th power. So 2.08 to the negative times 10 to the negative 35th power. All right, so same thing here. We're going to divide. Okay, so same concept as the multiplication, except I'm just going to divide these numbers. 2 divided by 7.6, I'm going to go get that answer, and 2 divided by 7.6, 0.26, so I have 0.26, and that's rounded to the nearest hundredths, times 10 to the, okay, and then I have my bases, 10 to the 14th divided by 10 to the 11th, so 10 to the 14th divided by 10 to the 11th. Make sure you subtract my exponents and you get 10 to the 3rd power. Excellent. And now, is 0.26 times 10 to the 3rd in scientific notation? No. All right, so this decimal is right here going now, and it's moving 3 places to the right. It should not be there. It should be 2.6 times 10 to the what power? To the 2nd power, right? So actually my decimal should be here. So now I don't need to move 3. I only need to move 2 places to keep that same answer. All right, so 2.6 times 10 to the 2nd power. And division, so I got 1.87 times 10 to the negative 6th power over 7.8 times 10 to the 14th. I'm going to take care of this part first. 1.87 times 7 divided by 7.8, and I get 0.24 rounded, I believe. Yep, rounded. And then times 10 to the, now I have 10 to the negative 6th, and divided by 10 to the negative 14th is? Excellent, 10 to the negative 20th, right? So I'm going to subtract negative 6 minus 14 and get negative 20, keeping my base of 10. All right, so now I have 0.24 times 10 to the negative 20th. That's telling me to move my decimal 20 places to the left. Is my decimal in the right spot? It's not. Where should it be?
2.4.
Good, so 2.4, and this is going to be 2.4 times 10 to the negative 21st. Excellent. So if I'm going 20 places to the left here, and now I move my decimal here, well, that means I have to give myself 1 more place to the left. So I have to move it actually 21 times to the left. So there's my negative 21 in scientific notation. Is 9.56 times 10 to the 15th, all squared. All right, so same concept with the exponents that we've been working on. So I'm going to square the first term, so 9.56 squared, I should get 91.39 roughly, and then times 10 to the, and I'm going to square this one, so 10 to the 15th squared is going to be 10 to the, excellent, 10 to the 30th. Again, just recognize it's not in scientific notation just yet. This is moving my decimal places 30 units to the right. If I put my decimal here instead, then I have to add one more, and this will give you 9.139 times 10 to the 31st power in proper scientific notation. Alright, so 6.26 times 10 to the 14th plus. Alright, so be careful because now we are adding. So with addition and subtraction, the rules are a little different. Alright, so plus 8.3 times 10 to the 12th. Okay, so you almost want to think of this as when you're adding like terms. If you have 4x squared plus 5x squared, what do you get when you add these like terms? You should get 9x squared, right? Keep your base x squared. 4 plus 5 is 9. However, if I wrote 4x squared plus 5x cubed, can I add these? No, right? So they don't have the same bases. They're not like terms, so I'm not going to add those. Well, same concept here, right? So I need these to have the same bases before I add them. So I have 10 to the 14th and 10 to the 12th. All right, so do they have the same base? 10 to the 14th and 10 to the 12th. They have the same base, 10, but do they have the same exponent? Okay, so just like my x squared and plus my x cubed, they have the base of x, but they don't have the same exponent. So what I want to do is I want to convert one of these, either the 14 and make this a 12, or make the 12 a 14. Now I'm going to go with the larger number. Okay, so 6.26, so I'm going to concentrate on this one, 6.26 times 10 to the 14th. Right, if I take it out of proper scientific notation, and I move my decimal over to the right one, so 62.6, this is going to be times 10 to the 13th. If I do it one more time, then this will be 626 times 10 to the 12th. Are you with me? So I move this decimal over 1, 2, and I turn this into a 12. Now that I have 6.26 times 10 to the 12th plus 8.3 times 10 to the 12th, well, I'm going to keep my times 10 to the 12th and just add 6.26 and 8.3. And what do I get when I add those two numbers? 634.3. And if I go back and put this into scientific notation, then this should be 6.343 times 10 to the, bring it back twice, so times 10 to the 14th. So that's one way. Right, so what I want to show you is the difference between these two methods. So very similar. Notice that I made my 12 a 14. I'm sorry, I made my 14 a 12, and then at the end I had to bring it back to becoming a 14. Yes? Well, let's play with this one. So let's do this the same. Rather than making the 14 a 12, let's change the 12 instead. So let's say 6.26 times 10 to the 14th plus, and now let's make this a 14. So what would this 8.3 turn into if I wanted to make this times 10 to the 14th? 0.083 times 10 to the 14th, right? So that means I move this over 1, that would change it to a 13. Move it over 1 more, and that would change it to a 14, because now I have to move it over to the right 14 times. Now if I add these, 6.26 plus 0.83, I should get the same 6.343 times 10 to the 14th power. So what I would recommend is bringing your smaller exponent to your larger exponent, rather than bringing your larger to your smaller. It won't make a difference. The only difference is, at the end, you'll just have to change it back. But either way is fine.